All right, today we're going to do the second step or second part of 5-2. That's solving polynomial equations algebraically. And so we're still using factoring. So this is still all very important from before. Again, I delineate this chart by saying that you should always look for a greatest common factor. That will not always be all you have to do. In fact, we're going to see on our examples today that is very much not all you have to do. It is just something that helps you make the problem easier to work with. So once you have done that, then look to see the number of terms. For our class, there'll be 2 terms. There'll be one of these 3 rules you're looking to use. If you can't use any of these 3 rules, then we'll talk about other ways to solve it, all right, eventually, or maybe we'll just be writing prime, all right. The 3, if there's 3 terms, that's what we're going to see a lot, and that's going to be the general basic trinomial factoring. And 4 more grouping, we'll definitely look at an example of that today as well. All right. And so, hey, what do you know? This is the first example, and it's grouping. So is there a greatest common factor? Does something go into all 1, 2, 3, 4 parts? Nope. Nothing, no number besides 1 goes into all of these numbers. X goes into the first 3, but not the last one. And so I'm going to split it. I'm going to say it's split right down the middle. Now, if it wasn't in order, I would put it in order first and then split it. Right? And so what goes into the first 2 parts? What goes into these first 2 parts? 4 goes into both numbers. X squared goes into both things. So I'll pull the 4x squared out. 4 times 1 makes 4. X squared times x makes x to the third. 4 times 3 makes 12. X squared times nothing. Or remember we said you could think about it as if you were dividing both things up here by that greatest common factor you're pulling out. You should still get this same thing. Down here, what goes into both parts? 9 goes into both parts, 100%. Now, the way I think of it is I want these things inside to be the same. So if I take just the 9 out, this is going to be minus. And I want them to be the same. So I want to take a negative 9 out because I want what's inside to be the same. And so by taking a negative 9 out, negative 9 times x makes positive. Negative 9 times x makes negative 9x, but that's positive x. Negative 9 times positive 3 makes negative 27. Or if I go back in my reverse thinking, I divided both of those by negative 9 to get my x plus 3. Now grouping is when these 2 are the same. When these 2 are the same, I can just group the coefficients in front, the parts that are in front together. Right? And so I end up with this. Now, I can be done there or I may have to check. This thing, does it break down more? Is 4x squared a perfect square? Yes. Is 9 a perfect square? Yes. And so it breaks down to 2x and positive 3, 2x and negative 3. And now if I was to solve this, I have to set each part equal to 0. So again, once we got to this step, we had to see, is there more I can do? If not, I still am equal to 0 right here. But there was more I could do. And so now I do the more before I set each part equal to 0. And so this is where we ended off the last slide. And so now I set each part equal to 0. 2x plus 3 equals 0. 2x minus 3 equals 0. X plus 3 equals 0. Right? First step here would be minus 3 to both sides. Then you would have 2x equals negative 3. Divide by 2, you would get this. First step here would be to add 3 to both sides. You get 2x equals positive 3. Divide by 2, you get this. Right? Over here, you would minus 3 to both sides, you'd be done, so you would just get that answer. Again, it's better to leave things in fractional form than it is to write out decimals, but I would take either right now at this point still. Again, it's also x to the third, so I should have expected 3 answers, and lo and behold, got 3 answers. So let's look at another example here. First, greatest common factor, something going to everything. Well, by golly, yes, it does. X goes into everything. And so x times x squared makes x to the third. X times 12x makes 12x squared. X times 20 makes 20x. So now, does this break down? Remember, it's a trinomial, 3 parts. So I have to think, what numbers multiply, but then add. So what numbers multiply first? This is first. This is second. All right. Multiply first. What numbers multiply make 20? 1 and 20. 1 plus 20 makes 21, not 12. What numbers multiply make 20? 4 times 5. 4 times 5 makes 20. 4 plus 5 makes 9. What numbers multiply make 2 times 10? 2 times 10 makes 20. 2 plus 10 makes 12. Winner, winner, chicken dinner. All right. Or you can always make the whole chart there. You get 20. That could be 1 times 20. That could be 2 times 10. That could be 4 times 5. Which one of those adds up to 12? 2 and 10. So x plus 2, because it was positive 2. X plus 10, because it was positive 10, equals 0. There's no squares or anything here, so I got that as factor as I can get it. And so now I set each part equal to 0. X equals 0. X plus 2 equals 0. X plus 10 equals 0. Here I minus 2 to both sides. Here I minus 10 to both sides. And so I get all my answers. Well, this one was done already. X equals 0. This one now is x equals negative 2. And this one now is x equals negative 10. Again, it was an x to the third problem. I should expect 3 answers, and we got 3 answers. All right, what is the greatest common factor here? Hopefully you said it was y. Y goes into all 3 parts. And so that's going to be the greatest common factor that I factor out of the equation first. Okay. And so now, what numbers multiply to make positive 5, add up to negative 6? Now, again, I don't really consider the negative first, so positive 5 to 6 is 5 and 1. Now, it's negative 6. So 2 negatives multiply to make a positive, but add up to make a negative. Do they break down anymore? No, they don't. So I set them equal to 0 individually. This one over here is already done. All right. Here I would have to add 5 to both sides. And so that's going to give me y equals 5. But now it is done. Here I would have to add 1 to both sides. But that's going to give me y equals 1. And so now it is done. I have 3 answers. I'm good to go. What is there, I should say, a greatest common factor? Yes, the greatest common factor is 2x. 2x goes into both things. Right. Now, does this break up more? Yes, it does. It's a perfect square. So 2x just stays 2x, but this one breaks up because it's a perfect square, a difference of squares. X squared becomes x and x. Has to be a difference, has to be minus. 4 becomes 2 and 2. And because it's minus, 1's plus, 1's minus. Now I set each part equal to 0. On the first one, I divide by 2. I get x equals 0. Good to go. On the next one, I add, I didn't mean to do that, x plus 2 equals 0. On this one over here, I minus 2 to both sides. And so I get x equals negative 2. And then on the last one, I add 2 to both sides, so I get x equals positive 2. There's your assignment from the book. Good luck to you.